Hello and welcome to the PASS Business Analytics webinar series. We're excited you could join us today for Jordan Goldmeier's session on creating outstanding spreadsheet models. My name is Vicki Van Dam, and I have a few quick introduction slides before I hand the reins over to Jordan. Jordan is an Excel MVP and an internationally recognized spreadsheet and data visualization expert. He's the owner of Cambia Factor, a data consulting agency, and the author of Advanced Excel Essentials. Jordan challenges companies to rethink how they use their data by focusing on returning value rather than acquiring and implementing new technology. He has consulted with and provided training for the North American Treaty Alliance, the United States Air Force and Navy, the Pentagon, the University of Cincinnati, the Financial Times, and many others. If you want to connect with Jordan, or if you have any questions after watching this webinar, you can contact him via these mediums here. The PASS Business Analytics Conference is on April 20th through 22nd this year in Santa Clara, California. The conference is designed to follow the analyst's journey, from sessions covering the discovery, analysis, and visualization of data to communicating insights throughout your business. Along the journey, you'll gain the critical business and data and analytics skills you need today to stay ahead of the curve. Industry experts and professionals will show you how to use technology to uncover insights and deliver new value to your organization. The unique design of the conference will give you the practical and indispensable knowledge which you can use immediately. So without any further ado, I will hand things over to Jordan for his presentation. Take it away, Jordan.
Well, thank you, Vicki, for that wonderful introduction. As Vicki said, what I really do is I talk about how we can rethink our data. So when I encourage companies to really invest in their data versus and really in themselves versus acquiring new technologies, it is a bit of a counterintuitive thought. And I want you to keep that in mind as I go through this presentation, because as many Excel MVPs are, I'm very opinionated, and you may not agree with everything that I'm going to present here. But what I really want to drill down on is that it isn't necessarily about rules, and I do present guidelines here. It's not about rules or principles. It's about thinking about the problem differently. So if for nothing else, if what I present goes against what you have learned or what you have commonly thought, try to put that advice in context. It may not be that I'm right for your situation, but there may be an underlying concept that is correct. So what I'm presenting is essentially a set of guidelines and principles and things to think about in your own spreadsheet models. And I know everyone has an idea of what spreadsheet models are for them and what's required. We're going to deal with some of those ideas and why I think many are not very good. But please keep in mind as you go through it that this is meant to really have you think on it and think how you can do things differently. So if I had to sum up what makes a proper spreadsheet model, if I would be so daring as to do that, I would say it comes down to three different things. Layout and design, the first, mechanics, the second, and data visualization and presentation. Now chances are none of these items are new to you, and to be fair, some of them actually overlap, and we'll see that going forward. So let's take a look at layout and design for a second and what we mean about that. Well, what I personally mean is that you have a layout such that finding errors and removing them or dealing with them is easier to do, and that I don't think is necessarily a controversial thought, but you really should keep that type of layout in mind. And also, as another part of it, clip art and word art really don't have a place in these spreadsheet models. It's particularly clip art. I suppose you could get away with some word art, but the point being is that these things don't really add value to the proceedings. They don't add value to your dashboards or your models. I think some people have said, well, it will help break the monotony of using this spreadsheet, which is kind of a bizarre argument considering what your spreadsheet is supposed to do, especially a spreadsheet model, which is to help businesses make better decisions. So the second part, mechanics, deals with slow formulas and code, and we won't really deal with code here. What I mean by VBA code, that's for another presentation, but we will deal a little bit with slow formulas. So slow formulas are ones that are volatile, and if this idea of volatile functions is new to you, you'll see that very common functions in Excel can be slow, and they are often responsible for slowing down a spreadsheet. So another part of this that's often forgotten of mechanics is to create spreadsheet formulas that are themselves not complicated, and we'll describe the reasons why. So then the final item is data visualization and presentation. So good data visualization techniques. I think data visualization is a bit of a buzzword right now. Obviously, it's important to help, and as you'll see later in this presentation, it helps us understand very complex data in a very simple way, and we are able to do that because there's actually ways our brain has evolved to see information. So when we use those items, when we use those evolutionary items, we can actually make better decisions. And I think often it's the case that we put data visualization on spreadsheets for the sake of data visualization because we think that we need it and we know that our management likes it, but we haven't put a whole lot of thought into taking advantage of those attributes and subconscious subliminal processes that our brain uses. So, and as another part of that is useless embellishment. Obviously that overlaps with layout and design, but remember, we do want to keep this, we want to keep extra information to a minimum. We want to focus our attention on the message. So let's go forward. So let's talk about what a model is. A model is a simplified version of reality. So what we mean by a simplified version, and you may have heard this before, is that all models are wrong, some are useful. So by their inherent nature, a model must be wrong because it's a simplified version of reality. So someone might say, oh, well, my model predicts this and therefore it's right. We have this sort of privilege we give data in society. We think that just because it's on a screen or it comes from a model, it must be right. That's not actually true, and we won't deal with that too much here, but it's something worth mentioning as we go forward. So what is a spreadsheet model? A spreadsheet model is the application of a model within the spreadsheet. And typically when we're talking about spreadsheet models, particularly in Excel, we're talking about making predictions, capturing an idea, trying to understand an underlying relationship. That relationship could be something like, well, if I sell product A, how likely am I to sell product B? I know I have a hypothesis that says that these two often sell together, but what is the likelihood? So there's another question underlying all of this because there's tons of different software out there. Why even use a spreadsheet at all? So the answer to that is that it's relatively cheap to use a spreadsheet, and I'll just talk about this point, which actually appears in my other talk at the past BA conference, which is that we have a bias such that when we spend a lot of time and a lot of money and effort on a model, or really on any sort of data product, we're less likely to question the results. We're less likely to understand them and interpret them in any other way that's that would help us out. So we want to be biased towards having positive results in that model. So in a small way, spreadsheets, because they are cheap and ubiquitous, and they don't take a lot of time and effort to create a model in, they are a safeguard against this. Now, it's not, obviously, it's not a complete safeguard, and I talk about that in my other talk, but this is something to keep in mind. So this is one good reason, outside the idea that Excel is great and it's good for a lot of things, but in a very generic sense, using spreadsheets for the process of modeling is a good idea so that we can at least safeguard against these biases that we have. So let's talk about the goals of what we're trying to achieve inside with our data model. So the first idea is development memory, and I put this in quotes. I'm not really sure if I coined this term. I think I did. I'm sure someone else has a better name for it. But basically, you all know who've worked with spreadsheet models before that you do work, and then you come back to it 6 months later and you think, what did I do? So develop memory to the extent possible is the concept that the underlying work you do should be easy enough to understand later. And I don't have to tell you why that's useful. I think you understand it immediately, because when you have an underlying nature that's being presented in a spreadsheet such that you can pick it up later, you are not, I guess, to say, beholden having to learn that information again. And the same idea of development memory is that it can be transferable, meaning that if I give this to someone 6 months later, it should be built in such a way that they can understand it. So the other goal is model transparency, and that refers to the degree you are able to understand the underlying methodology, and not just understanding the methodology. It's not just enough to understand what's going on in an intuitive sense. You need to be able to see the errors. So I think a lot of people build spreadsheets. They don't have this idea of error propagation in mind. So we all know that most spreadsheets have errors in them. That's not news. but you should build in such a way that it's not a black box. You should be able to find errors. In fact, finding errors is a good thing because then you can deal with them. It's much worse when your spreadsheet has errors. And again, just by sheer probability, it will have errors and not be able to find them. So this is an idea of model transparency. It's one of the goals of this presentation. So if you take the information here, that's what we're trying to reach. It's one of our objectives. And then finally, model efficacy. So what do I mean about efficacy? I mean that you have the confidence that this model is going to do what it says it can do, and not just do it by taking 6 hours, you hit a run button. No, it should be able to do it quickly and effectively, because your use of this spreadsheet should be something that you're able to sit down and do quickly. It's not, if we have to wait 6 hours, then we're disconnecting essentially the message and our usage of it. So it needs to be something that's fluid. So again, those goals are development memory, model transparency, and model efficacy. So keep those in mind as we go forward. So let's talk about layout and design. Remember, that's one of the areas. We're going to talk about it in depth. So one of the items of layout and design, at least for me, is the idea of following a good naming style. So we often, at least I should say, I often see this in other people's spreadsheets, and I used to be one of the clear offenders in this way, is that we use tabs that are filled with abbreviations that we don't understand. So when I say tabs, I mean worksheet tabs. We also name files in bizarre lexicons that are abbreviations and underscores. Really, there's no reason for this. We should be using clear and descriptive names. We should also be implementing good model layouts. So what do I mean about that? I mean that the raw data are separate from the calculations and presentations. And we'll go into that a little bit more in depth. We should also be using worksheet tabs judiciously. What does that mean? It means that we shouldn't be separating ideas across tabs. It's often the case, and we'll talk about this later, that you see data that could be laid out in a table will be separated, say, by year, by product, things that we could actually see all at once. Or we'll say, instead of 3 charts on one dashboard tab, it will be each tab will have a chart. And I think the idea behind this is that you can separate the ideas, and then you can write the purpose for each chart. Well, I'm here to tell you that that is not a good way to run your spreadsheet models, because for one, as you separate that information, you don't understand it as a whole, and for two, you are adding extra file size. So often it's the case that a tab that already has a whole bunch of information on it is copied and then pasted, and then it's updated to reflect another chart. And what you're essentially doing is copying all that text, all that formatting, all that chart data, and recreating it. And I'm really here to tell you that's not necessary. There are ways around that. Another item as part of layout design in depth is keeping formats organized and clean. What does that mean? No clip art. Really, no clip art. It's not necessary. You don't need to put shadows under your charts. You don't need to put them under your words. Remember that the message here is the model results, or it's how to understand the model, or transparency. None of that actually fits into our objectives. And you should only include instructions that are sufficient enough to understand what's going on. It's often the case that I see models that are filled with instructions. That is not the place for them. Keep them in a Word document. So let's go into these items in more specificity. So here's a list of rules I have for naming your spreadsheet. And again, this probably goes against the grain. So even if you don't agree, you should think about this a little bit more. So you should use complete words. So we'll see in a minute what that entails. You should not use abbreviations unless you're abbreviating proper nouns. So what does that mean? It means if you have an example file, so I always see this, example dashboard, don't write EX dashboard. That's not necessary. And you should always connect words with a space. So when I say here EX dashboard, that's also a violation. There's no reason we can't write example space dashboard. We're not limited anymore by characters. We're no longer in the era of DOS. You should use numbers to show incremental changes in the latest file version. So we'll see that in a minute. It's often the case that we have very weird archiving habits when we name our spreadsheet files. We may put our names at the end and add a 1 and then a 1A. You don't need to do that. And this is really my own personal thing. I know I run up, against a lot of criticism for this, but you don't need to put the date inside a file name, be it Excel or any other file name. We'll see that in a second. But there's no reason for it because that information is actually already stored. And what I've found personally is that you give a file name a date and then it disconnects. You may use that file later and you have not updated the date on that file name. So what we have is a disconnection in the title. And some people may say, well, who cares, it's just a title. But I would still say that it's very, very important indeed. So something to keep in mind. So let's move forward to see this in practice. So over on the left, I have the thing that I've complained about. So the question here is, what is the latest file name? And by the way, this is not really just taken out of nothing. I've adapted this from a real problem. So which one is the latest version? Well, if you looked at this, it wouldn't be clear immediately. In fact, the latest version is the sales-04 3 2012 5/9 2013 B. So this is not a good way to name our files. And in fact, you can see here it's not even very readable. If I move over here, I see that I have something called a sales dashboard. I've used an incremental number at the end. Now, if I sort these inside my Windows Explorer by their name, the latest version is either always going to be on the top or always going to be on the bottom. So this is a great way to do version control. And then, of course, over on the right, we have a date modified. So you don't need to put the date in there. So let's look at Worksheet tab names in practice. Above, I have, again, an unfortunate spreadsheet that is actually something I've pulled. And here we have just different names. We have that sales dashboard, and there's an underscore, and it has a version number, and I also have different colors. It's not actually clear to me what is going on in each tab. And I know, again, that many, and we'll talk about these, many auditors or audit policies for spreadsheets have said, well, don't worry about that. Well, they don't say it like that, but they say put the purpose of the tab on that tab itself, so write some instructions there, which, as I told you, is not a good idea. But really, we should think about this and say, well, why not use descriptive names? Why do we have to make more work for ourselves? So I submit you should use very descriptive names. Keep the uppercase letters to a minimum if you can. Keep the abbreviations, except for proper nouns, to a minimum. Don't use jargon that only you understand. Don't use a system that only you understand. That's part of having good development memory. So let's talk about proper model layout. This is actually an adaptation of the N-tier layout. And you've probably done some version of this if you've done any models in Excel. So I call this information transformation presentation, and I like that because it rhymes. The information is where your back-end data resides. Often this is a worksheet tab. The transformation is where you perform calculations on top of that back-end data. And the presentation layer is where you present that information and results. And this is very important to actually have at least these three layers. So you usually don't touch the information on the back end. That's raw data. On the transformation layer, you are doing work on top of that. So that raw data is always maintains its consistency. And on the presentation layer, you're actually showing the results of those transformations. So we'll see here in a few minutes why that sort of dynamic is so important. So just to give you an idea of this visually, so we have the information layer here. And then we have some sort of transformation. In this case, it's a pivot table, and that pivot table informs a final presentation. So why does this even matter? So first, we have this idea of separation of concern. So when we separate each area, we can actually better organize our work. And we also have the idea of auditing transparency. So if we want to audit these models, this sort of consistent pattern allows us to understand the flow of information. So we know it starts somewhere, and we know it ends somewhere, and we know linearly, if we just follow this straight line, how that information changes along. So this is really my favorite part, error propagation, because I don't think we actually talk about this a whole lot, but again, I told you at the start of this, a good model should help you find errors. So what do we mean by error propagation? Well, if I see a item on the visual layer that doesn't make any sense, I can actually move back to that transformation layer, and I can see if the error originates there. If it doesn't originate there, I can move one step back and see that it actually starts in the information. If it doesn't, if it doesn't exist on the information, then I've actually pinpointed the fact that it is in the transformation. So what it allows us to do is at all parts of the spreadsheet where an error exists, it helps bubble it up. So if it starts at the information, then it will move through the transformation and move to the presentation. We'll see it immediately. So by doing it this way, we're able to find and address errors, and that is a incredibly missed opportunity that many spreadsheet developers do not think about, and I submit that's actually why we have so many problems in our spreadsheets, because we don't think about this. We start from the ends first. We say, well, make it, and then do testing and look for errors. No, I say you should make it so that those errors essentially always break the model. And then we have this final idea of integrity of the back-end data. There will be no changes to it. This is actually a very interesting idea if you do any object-oriented programming, that, you know, inside of a class you can't change the variables inside of it without a get or a set method. Here, what we're doing is we're preventing changes to be made by that back-end data by keeping it in this dynamic. The only way to change that data is through the transformation layer. So that's why this is very important. So we always know that there's integrity in that back end. So let's talk about clean and organized layout. Here I have a layout that's all too common, unfortunately. I have a gradient that really has no reason to exist here. And I have this byline created by John Smith. If John Smith worked for me, I would have to talk to him about his spreadsheet skills. But here we have this issue. There's no reason for all this formatting. There's no reason to have a byline. Who cares what person made it? I'm not saying you shouldn't put the organization, but this isn't something that needs to be on the spreadsheet or on the visualization layer itself. In addition, these Office clip art items don't help either. And even as people sit here and shake their heads, it's important to think back and say, well, did I ever make any embellishments in my buttons or in these bylines or even in the title that weren't necessary? Did I really need that gradient? Did I need a picture of an extra item here to understand that we were talking about office supplies? I'll actually have an interesting story about that later. So here's what we mean by clean and organized layout. I've removed all that gunk, so to speak, all that useless color and shadow and things that really did not help deliver the message. So some folks will say, well, this is what management has asked for. They need this to understand what's going on or to be interested. We're actually going to deal with that later in the presentation. But just to keep an eye on this, which looks better? Well, obviously the second one looks better. So I'm going to just keep on this theme of clean and organized layout. The left side shows something that really irks me, and it's not just me. It's folks like Stephen Few. There's no reason to create a table such that the titles have to be turned. This is not how we read intuitively. It's much better to leave them flat. In fact, again, which one looks better? Which one presents the information in a better way? Another idea, at least on the left, we have these titles again are being shown on the side. Now the question here, there's a bit of a debate whether the colors on the right are actually better than the colors on the left. I tend to think that they are, but since we're showing categorical differences, there's an argument to be made that the colors on the left are fine. But what I want to just draw your attention to is that, in fact, the one on the right is less visually overwhelming. It doesn't need those grid lines going across. The message that it's trying to deliver in terms of information is actually a lot easier to understand. And again, I'm open to disagreement here, but it's worth thinking about the one on the left and one on the right and say, well, is there a middle ground here? Is there a way that I can present information such that additional ink, as Edward Tufte, the visualization guru, would say to get rid of? So we want to increase the data ink. That's the part that delivers the message, and get rid of the chart chunk is what he calls it, the part that actually takes away or at least doesn't add anything to the message. So why does this even matter? Always a good question. Extra images and embellishments, such as those clip art, they increase the file size. And you know, if you're going to send this around via email or you have storage limits, there's no reason to increase the file size. Obviously, the greater the file size, the longer it takes to open. So we want to at least bust over those myths that Excel is not very good with handling a lot of data, and I submit that the reason people think that is because we include all these embellishments and needless formatting in our spreadsheets, and we make them huge for no reason. Presentation without distraction increases the comprehension. So again, I don't need to make this point. Everything you see on the screen is actually coming into your brain. So If you add extra clip art, if you add extra embellishment, well, that competes with the actual information. And so bad data visualization actually decreases comprehension. Again, if we're not using the tools that we understand about data visualization, we are not delivering the message as effectively as we could. So here's another item as part of our design and layout. You don't need to add detailed instructions inside your spreadsheet. So small instructions are okay. And by that I mean a 1 or 2 sentence item that says, put your name here, put this item here. There's no reason to have full instructions in the spreadsheet. I know many have argued and said, well, how will people know how to use it? And I'll tell you what I do. I use Word. Why not use Word? In fact, with Word, I can use headers and I can create a table of contents and I can hyperlink those items in the table of contents, and I can use a program like GreenShot to help me take screenshots, or you can use print screen. But in any event, I can put figure titles and I can more easily tell the user what's going on and deliver that as a PDF manual. So the most important part of this, because I've seen instructions in spreadsheets before, is that they add extra weight to the file size. They add, it's just another thing for Excel to take care of. And Excel's not a word processor. It wasn't designed to provide instructions in this way. Now, Chandu has a really interesting way of providing instructions where he has shapes, and you can hit show instructions, and they quickly show you and tell you what to do. That's a much better option than having incredibly detailed instructions inside your spreadsheet. They don't need to be there, and why not use a program that was designed for word processing, Word, to create those instructions? So let's move on. We're going to talk about mechanics in depth. So let's think about what we mean by mechanics. So slow formulas in code. So we want to avoid formulas that are going to slow our spreadsheet down, and those are called volatile formulas. And we also want to avoid formulas that we won't understand later what's going on, because that slows us down as human beings, as developers. So we should always be designing for readability. Formulas in your work should be designed such that you and others can quickly understand what's going on. We want to root out spreadsheet errors. Many people don't know this, but spreadsheet errors, in fact, slow down a spreadsheet considerably. If you're wondering why it's slow, it's often because you have too many of these spreadsheet errors. Many folks believe, well, this input isn't filled in, and it was going to be another number is divided by that input. So right now, because it's not filled in, it's a 0. So division by 0 errors are very common. But the other common reason is that we have artifacts of our own work hanging around the spreadsheet, and we've sort of forgotten about them. We should always be avoiding volatile functions. Obviously, I've spoken to that quite a bit, and we'll speak to it a little bit more. We should avoid complex ifs. Ifs are probably the most, nested ifs, I should say, are probably the most common formula in Excel, and they have their own set of problems. So as a segue to that, and we'll see later, we should be using natural formulas. And what do we mean by that? We mean formulas that naturally reflect the underlying problem. Well, that's a very interesting concept, and I'm sure you're excited to hear about it. So let's get to all these ideas here soon. So designing for readability, you can see the top formula is just one long string of information. But in fact, if you drag that formula bar down, you can make this formula much more readable. And the way to do that is once you've increased the size in your formula bar, you can use Alt-Enter, that combination, to make a new line in Excel's formula bar, and that way you can separate different items of a complex function. So if you just look at the top one and you look at the bottom, which one is easier to read and understand? Obviously, the second one is much easier to read and understand. And remember, that's Alt-Enter inside the formula bar. So what you could also do is assign a name range, and name ranges make our formulas a lot more readable. So here I have a cell B6, and I've given it the named range. I've given it the name, the droids you're looking for. So if the droid you're looking for is false, of course move along. Otherwise, I imagine you want to wait. So notice what I've done here, and we're going to talk about this a little bit later here, is that I've given this named range a proper name that actually describes the underlying problem. You look at this and you say, oh yeah, I remember that's from Star Wars. It's actually very easy to understand what this formula is doing. Think about your own formulas. Is it as easy semantically to understand what's going on? And that's why named ranges are important. And notice also I have actually used a full sentence here of description of my named range. I haven't used a bit of abbreviation that only I understand. So we also should try to look for spreadsheet errors and correct them. The easiest way is just, if you understand your model, if you followed ITP, well, you can actually follow the way your data moves through your model and see those errors. But if you suspect there are errors in your backend spreadsheet and you don't know where they are, you can use the Go To Special feature. And that is on the Home tab. You would click Find and Select, and you click Go To Special. There you would select the formulas and uncheck everything else except for errors and hit OK, and that will help highlight the errors in your spreadsheet. And so you can either delete them, or alternatively you could use if error. So how if error works is in the first parameter, you see I've supplied an argument. That argument is actually the original expression of what that cell was going to be. So initially that cell was equals A1 divided by B1, and I put an if error around it. And then that second parameter, the argument I've supplied here is a message. Now, it doesn't always have to be a message. In your case, you may just want it to be 0 if there's nothing to divide by. That perhaps that number is naturally 0 if that input isn't there. But by doing this, you've actually handled the spreadsheet error. And if something relies on it down the road, you put a 0 in there. You could put test down the road, and by down the road I mean using ITP. So going into your transformation and then presentation, you know that you've handled this error, and you can deal with if you know that error might exist either because an input isn't going to be filled in or because some sort of raw data it's such that it would cause this error. This is a way to handle it. So let's talk about volatile functions. I know I've talked about them quite a bit now. So if you've never heard of a volatile function before, the way they work is that they recalculate every time you make a change to the spreadsheet. And by change, I mean of what we would call a volatile action. So what are volatile actions? That's typing in a new number in a cell. That's adding a row, deleting a row. Very common actions will cause volatile functions to recalculate. So the very common ones, volatile functions that we see are offset, indirect, today, now, and rand. Now, rand is an easy one. Obviously, you want that to recalculate because it's generating a random number. I don't think many have thought that offset or indirect are volatile. And truth be told, I don't even know why Microsoft made them volatile. And obviously, today and now are volatile for the reason that they present today's date. So you always want that to be updating. So there are ways around this, but keep in mind, if you use too many of these volatile functions, it will slow down your spreadsheet. And I will submit this. You should rarely, and I mean this, you should rarely set the calculation mode in your spreadsheet to manual. If you find you're doing that, chances are you're using too many volatile functions. You should definitely not do it in a final product. It's one thing if you get a set of data in and you need to do something to that data to make it usable as the raw data for your model, but you should really never have the calculation mode set to manual in your final work because that presents all sorts of wacky results and all sorts of wacky problems. It's not something you should mess with. And the way around that, because I know many people are saying, well, I can't get around that. Well, of course you can. You can use index instead of offset and indirect. You can use a macro to create a timestamp on the project instead of using now and today. And you should always, and this is funny because people will use rand or rand between to generate fake data, and then they'll forget it's there. So you should always make sure to remove these volatile functions from your spreadsheet. So let's talk about that idea of using natural formulas. Obviously, this is actually one of my favorite concepts. So I took this example that's being shown here from Microsoft's help website. So what they're presenting is a case in which you want to figure out what letter grade a student received given by the score. So you can see these formulas. So here we have if A2 is greater than 89, they received an A. And then it begins nesting, correct? So if it's greater than 79, they receive a B, greater than 69, a C, and so on. So we have a nested if problem for letter grades. So the question I want to ask you is whether this is a natural problem, or at least if nested ifs are a natural fix for this problem. And the answer is no. No, they're absolutely not. And you have to get a little philosophical about this. So actually, I'm going to jump back on that slide. And I know this is hard to really think about, but is the reason, just think about it this way, is the reason you didn't receive an A in the class, is it because you didn't, or let's jump to B. Is the reason you didn't receive a B in the class because you didn't receive an A? Well, no, it's not. The reason you didn't receive, or the reason you receive a certain grade is where it falls in a certain scale. So thinking about it this way, ifs are best, in this case nested ifs are best for compounding branching conditions, where it is the case that the final result naturally extends naturally extends from these conditions. So it is not a condition that you did not receive an A, therefore you receive a B. In fact, again, this is a lookup problem, so I'm jumping ahead here. We can see a much better way of doing this. I've used match and index here. You can always use you can use other items such as VLOOKUP depending on how you create the problem. But again, this is a natural lookup problem. The compounding ifs don't help us understand it. And this goes back to the idea of development memory, because looking at this spreadsheet right here, I can more easily understand the underlying problem, which is that I want to know my grade based off of these score ranges. It's much harder if I suppose we know about A, B, C, D, and F. That's really how we've been culturally accustomed to understand how grades work, but it is still much harder to understand what's going on here versus what's going on here. Not only are there fewer formulas, it actually is easier to understand because it models the underlying problem. And I submit to you that your formula should never make the problem more complex than it needs to be, that it should actually be a natural extension of an underlying problem. This is something to think about, because we often think, well, we just want a solution. It doesn't really matter what the solution is. But what I'd like for you to think about is that if you are going to use work in a professional setting, and you may have to look at it later, or someone may have to look at it later, it really should make a difference about how you solve that problem. Because when you make a formula that's too complex, you end up solving the problem of that formula and figuring out why it's worked, rather than trying to model the underlying problem itself. So let's look at another one, because this is a very common one. Here we have a product ID, and we have an item size. And here we have a natural ordinal scale. And for those who are new to this idea of ordinal, it just means that it naturally ascends or descends. We know intuitively that small is less than medium, which is less than large. So we have these categorical values, and they are mapped to a certain product ID, and remember that they are ordinal. So one common way of doing this, again, is with the idea of nested ifs. And think about this. Is this a branching condition such that if a short that we're interested in isn't a large, it must be a medium. If it's not a medium, it must be a small. Well, that's not actually how we should think about this problem, because it's really testing a scale using these product IDs. So that item size 1, row 7, that's really not a good way to model the problem. But row 8 is, and here I've used choose. And for those unfamiliar with choose, the way choose works is you supply that first parameter with a number. So in this case, it could be 1, 2, or 3. So if you supply it with a 1, it's going to return a small, because that's one parameter away. If you supply it with a 2, it's going to return what's 2 parameters away. And if you supply it with a 3, it's going to return what's 3 parameters away. So think about this for a second, because the second formula clearly more naturally models the underlying problem. We see intuitively what it's doing. Even if we've never even heard of choose, once we know what choose is, we say, oh, that makes complete sense. Versus the one above, it may not make complete sense because it's not a natural match. So think about this. On using nested ifs, you should use nested ifs when the problem naturally lends itself to branching conditions. I know I keep saying that, but really it's something worth considering. And here's a good test for it. If you can turn the problem naturally into a flow chart, into a decision tree, then you have a natural branching condition problem. And what you can also do is start from the end, and you can say, does a specific result naturally follow from not satisfying the other conditions? Again, the other problems did not. So here's what you should not do. If you use ifs haphazardly, because you can't think of a better way, I would say it's not a good idea just to patch things. You really should not use more than 3 nested if conditions in a cell. Is there any science to back that up? No, that's just my opinion. But really, when you think about this, perhaps there is some science, as I've just thought now. Our short-term memory can only hold about 3 to 7 chunks at a time. So if we have to actually go 3 layers deep, and we're already holding the other conditions in our brain, then we are starting to max our short-term memory. I just thought of that right now. You shouldn't write ifs in a way that only you can understand. So let's say you say, Jordan, you know what, forget it. I don't really agree with that, but please, this is something that hopefully we all agree with. You should write them in a way that everyone can understand. And by everyone, I don't just mean your buddy. I mean you 6 months from now. So let's talk about data visualization and presentation. So we should always try to employ good data visualization techniques if we can. So we shouldn't mislead with charts, and we'll see some examples of that. We should avoid data occlusion. Now, what is data occlusion? That is when you present 3D charts, and some of those charts, some of those aspects of those charts occlude, they obfuscate, they hide data behind them, such that we can't even do what the chart exists to do, which is compare data. You should always try to show relevant data together. Don't needlessly separate charts into other worksheets. And it really is worth learning some data visualization principles, because this is actually a field that's been around for a long time. There's not a whole lot new in it, and there's some great books on that. Information Dashboard Design by Stephen Few, Edward Tuff's books. He has a series. All of them are great. And you should also respect your audience's intelligence. Now, this is very important because, and I'm probably going to get some pushback on this, but it's something worth considering. We often say that we need to dumb down the presentation and data for our managers. In fact, a story I have of this is when I was working as a defense contractor, and we had a presentation for a general, and there was a data visualization, and someone said, oh, we need to put this helicopter. This is some stock photo of a helicopter, which I suppose because this was for the Air Force. So they were interested in that. The stock photo of a helicopter on here, I suppose it was somewhat relevant to the presentation. So they did that, but it went over top this heat map that they had created. And I said, well, why are we showing this? We need to get rid of this. And they said, no, you don't understand. The generals really, they won't be interested in this without it. And I thought to myself, man, is that so silly? And then on another occasion where I actually had been speaking with a general, and we had sort of obfuscated we had added some of these embellishments. I remember the general had asked, well, what about this and that? And one of my colleagues responded, oh, well, that's down in the weeds information, because there's this underlying assumption that he would not be interested in down in the weeds information. But there's no real clear reason why people come in with that assumption. And in fact, the general responded, well, I live in the weeds. And then we quickly adapted our presentation on the spot. But you don't have to do that. There's no reason to do that. So whether it's this or anything else, this idea of presenting information like you're speaking to a second grader, or for a 5-year-old, this, I would say, throw that out. Have respect for your audience's intelligence. Now, if you are presenting overly complicated work because you think that's what they need, perhaps you're being overly self-indulgent and should question whether you're making work for the audience or for yourself. But if you are making work for the audience, and the problem is naturally complex, you should present the information in a naturally complex way. So don't overcomplicate it, but don't oversimplify it. Make sure that the initial intention is being presented. So let's talk about misleading charts. Here's a chart of voting results, and we have a for and against. And here, the keen observers here would know why this chart is misleading. It's because that 40%. It's because that the chart starts at 40% instead of 0. Now, if we keep going, I've started the chart at 0, and you can see that the difference from each chart has been overstated. So always start those bar charts at 0. Don't overstate the differences. Now, it's true that, in fact, this is a lesson to be learned across all disciplines, including the news media. Here we have a chart that is overstating the differences because it started at 34%. This is one from Fox Business News, a very common one, in fact, when discussing this issue. So keep that in mind, that just because it's presented on TV doesn't make it real. Always keep your suspicions open for misleading charts, both in the work of others and yourself. So here we have a 3D pie chart. So I ask you which slice is greater. Obviously, the blue looks like it's greater, and now I go forward one. I've changed the perspective on this chart, and now the red, the no, appears greater. It's funny how changing your perspective changes the information. In fact, if we show this in a non-3D visualization way, we see that they are equal. So remember, what we interpret is actually a function of how the information is being presented. You know, it's like that old saying, the medium is the message. That's probably not the correct usage for it, but something to think about. Let's talk about data occlusion. What is the value for product C sold by representative 4 in region C? And I'll give you a second to look that up. Oh, it's hard to look up, isn't it? We can't actually see it because it's being occluded by product A and product B. And this is, in fact, a function of our choosing a 3D bar chart for this. So there's no reason to do a 3D bar chart. There's almost always a better way. You don't need to show information in this way. So you should always try to show relevant data together. So over on the left I have what I consider showing relevant data together, you see that all the years are there. This information is being presented in a table, and the relevant months are there. This allows us to see everything all at once. Over on the right, I've sort of zoomed in on these different tabs, and this is a very common feature of what I consider bad model design, which is to separate this information on different tabs. You know, there's about 45 years in this full table. There's no reason to separate it in this way. So again, if you're having issues with this, showing relevant data together, one great way around that is in Excel 2010 and above is to use spark lines. Here I'm actually presenting the information that was shown in those months. I'm showing them in a very small way using these mini charts. So I'm just going to jump back real quick. You can see this information January, February, March, April, all the way through December. I'm showing that visually in a very condensed way. And here I'm able to show it together. So this really does a much better job than separating the tabs out because I can see all this information. And if we limit comparison, then why are we even doing this? Remember, comparison is a feature of data visualization. It's why we make charts. Why fragment data needlessly? We should try to show as much information together because that's what helps us make a decision. The moment we fragment, we put this information in our short-term memory, and we have to store it there, versus when we look at this immediately, this information is not being stored in our short-term memory. It's actually being interpreted very quickly by a different process as part of data visualization. So again, why separate these tabs? I know I keep hammering this point, but if we think about dashboards, and many people say they do dashboards and they put them on different tabs, but we should really try to show all this information together because it helps us answer a fundamental underlying question. There's no reason to separate these two larger charts out when we can actually understand it all together. So you should also take some time to learn data visualization principles. I'm going to give you a little bit more direction on that. So before I was just showing you 3D charts, all of that is part of learning data visualization principles and why those charts are terrible. So how many sevens can you count here? I'll just give you a second. Well, I'll tell you the truth, I actually don't even know how many sevens are there. I think I usually let people call out the answers and then I say, oh yeah, that sounds right, but let me just ask you now, how many sevens can you count? Well, how much harder was that? Let's just move back. How much harder was this versus this? Obviously, this is easier because we're using data visualization principles. In this case, they're called the pre-attentive attributes. We varied the hue. We've made something more of an alert, and this obviously comes to the front of our minds. And that uses a different process, again, than our short-term memory. This is a process that we've evolved to understand information. When things alert themselves to us, we take them in more quickly. And obviously, if we use a similar baseline, we see this, again, as much easier to count. How about this? Using the table, what is the second highest month? Well, to do this, we actually have to start with the first month, and then we have to remember, and then we have to look at the second month, and we say, is that one higher? Is it higher? I think it's higher. And we have to keep doing that. It's a taxing process, but again, it uses our short-term memory. Not particularly hard here with only a few months, but I submit if we use data visualization correctly, we see this immediately. We see that it's June, and we see that without doing the comparison. We see it quite quickly. You know, what else can we learn from this chart? We can see that the lowest point was in April. We see that, again, immediately. We don't have to do this, practice, again, of putting all that information in our head. And we can see where the highest point is, and we can actually see there's some seasonality here, where we see a process of from January to February, there's a slight increase, February to March, large increase, and then a decline, and we see that that keeps going on. And then something else that we see, it doesn't really matter if it's 10 data points or 1,000 data points. If it can be condensed and presented in this way, we can realize that information, the second highest peak or the greatest peak or the lowest peak, rather immediately, because if we try to do the practice that I did earlier, the exercise of trying to figure out what the second largest data point was, how much harder would that be if there were 1,000 data points? It would be much harder. It's such that I don't offer that exercise because it's nearly impossible without writing information down. So that process of writing information down, be it storing it in your short-term memory or storing it on paper, is something we want to avoid. And data visualization allows us to avoid this because we can use other processes in our brain to see information immediately. So remember, what we perceive isn't necessarily a function of how many data points are available. Again, we can have thousands of them. If they can be reduced to a chart like this, we can see that information immediately. Remember, the rule of thumb, just like formulas, charts should always matched the underlying problem here. We have, again, an unfortunate common practice where we have a line which is showing trend, but we have categorical variables. There's no reason to do this because pineapples, there's no trending towards pineapples. The order of these categories has nothing to do with any underlying ordinal scale. Grapes are not bigger than apples in any sort of way that we're measuring this. So, in fact, this problem would be much better with a bar chart. So, remember, respect the audience's intelligence. You should use appropriately complex visualizations to model a complex idea. Your charts should naturally model the underlying problem. And you should have enough confidence in yourself that you can actually present these ideas. And that's part of having model efficacy. Can my data model do what I think it can do? And presentation's part of that. You should use charts you believe in. And hopefully the ones you believe in are the ones that are correct to model the job. Pie charts are generally not one of those. If your management objects to it, you should actually try to do a side-by-side comparison of your idea versus what they have. You don't always win, but again, as you saw intuitively, why these ideas are better, hopefully they see that as well. You should ditch and ignore advice that says your audience is in a second grade, that you need to explain to them like they're a 5-year-old. I don't really know why we believe that, why that that idea keeps permitting itself. So often you have leaders in charge who say, well, I want it presented to me in that way. And I hope, if I can speak to you, that you really should not want it presented to you in that way. You should want it presented in a way that you can understand. You obviously went through schooling. You got to where you were by understanding complex information. So don't decide to dumb down your own work because you don't think you can understand it. And if you don't think you can understand it, then do the adequate research data visualization books, obviously one of them. Very easy stuff, not hard stuff. Don't believe that your presentation is going to be more interesting if you do embellishments and 3D charts, or think, well, I can't really see a justification for a 3D chart where that information is included. I think some folks say, well, adding 3D really helps people understand. There's no academic or scientific research behind that. Perhaps if we keep telling ourselves that, we'll believe it, but there's no reason to believe it, as I've demonstrated here. Remember, the message is the most important point. Don't just use a chart because management says so. You've got to present your information accurately. Remember, again, the message is the most important. Use as much as you can to help naturally present that message and naturally reflect the underlying problem. So let's just go back to our goals, and remember, we can see here how they fit in. Develop memory refers to the way that you design your work, and how if you have to give it to someone else, that memory of what you did goes along with it. It also goes to yourself in 6 months. Model transparency being how hard it is in your ability to understand what's going on underneath that model, and model efficacy. Really spoke about that in that last part, that you should be able to quickly, intuitively describe what the model does. The model should do what we say it can do, so the visualization layer of that model should present information in that way. So, in conclusion, remember, layout and design, mechanics, data visualization, and presentation are the important points. The degrees to which we can maximize, or at least think about the underlying problems and how they manifest themselves in these buckets, how we can maximize these areas, that will really help us present information better. It will help us create better models. Obviously, you know, most people don't think of naming convention of having good as a good model practice, but this is why we have problems with archiving models. This is, in fact, you know, so much work is being done to satisfy Sarbanes-Oxley, and much of this work is overcomplicating things with abbreviations. Why not do what is simple and do what works? And that's the conclusion. And now here's Vicki.
Thank you very much, Jordan, for a great session. For those of you listening, if you're interested in accessing other free educational content, the PASS organization has a variety of virtual chapters which offer free webinars to their members every month. Check out upcoming webinars and recordings of past webinars from our business analytics, Excel BI, business intelligence, big data, and cloud virtual chapters by visiting www.sqlpass.org/VC. And once again, the PASS Business Analytics Conference is April 20th through 22nd in Santa Clara, California. Visit passbaconference.com to check out the great lineup of speakers who, along with Jordan, will be presenting at the event this year, and also to register. And finally, just a reminder that Jordan will be joining us at the conference, and he's got 2 great sessions that he's presenting this year. One that will follow along from this session, creating outstanding spreadsheet models, and a second, which is making better decisions with data. So thanks again, Jordan, for a great webinar, and thanks to everyone for watching.